Welcome back to 3 Inquisitive Kids. In this video, we will be going over 2 problems on equations and inequalities of absolute value. Solve for the absolute value of the sum of x and 5 plus the absolute value of the difference of x and 3. And this equals 2. So then what would x be? There are 2 approaches to look at this problem. The first one is we can start off by drawing a number line. This is 0. And we need to find the 2 key points to draw. And the 2 key points are the points that x would equal if each of these absolute values equals 0. So it would be x equals -5 in the first absolute value, and in the second absolute value, it would be x equals 3. So then we can plot out the points 3 and -5. Doing this, we have already split this number line up into 3 sections. One is x is equal or less than -5. The other one is x is somewhere between -5 and 3. And the third section is x is greater or equal to 3. So we can split this problem up into 3 sections and think about each one separately. So for the first solution, we have x is less or equal to -5. Then it tells us how we can take away the absolute value symbols. Since x is a negative number, we would have to flip or reverse all of the symbols in the absolute value. For example, x plus 5 turns into negative x minus 5. X minus 3 turns into minus x plus 3 equals 2. So then after we get rid of these absolute value symbols, it's much easier for us to calculate for x. So we get -2x minus 2 equals 2. Then we get -2x equals 4. So then x equals -2. But is this possible? We already know, based off of the condition, we know that x is less or equal to -5. It has to be that. But then after calculating, we get x equals -2. Clearly, these do not equal each other, or they go against each other, which means that this first solution is wrong. So then what about our second section, which is when x is between -5 and +3. So how will we get rid of the absolute value symbols in this case? Well, looking at the first absolute value, we know that if x is in this section, we would get a value greater or equal to 0, which means that we can just have x plus 5. And what about for the second absolute value? In this case, we would have a value that is either equal or less than 0. So it would turn into negative, which means that for the second absolute value, we have to reverse all of the symbols to get -x plus 3 gives us 2. After getting rid of these absolute value symbols, we can go ahead and calculate. We have these 2 x's cancel each other out. We get 8 equals 2. Clearly something is wrong here because 8 does not equal 2. So this second solution, or the second range of x, does not work either. Now what about for the last range? X is greater or equal to 3. If x is greater or equal to 3, we don't have to change any of the symbols. We can just take away all the absolute value symbols to get x plus 5 plus x minus 3 gives us 2. 2x plus 2 gives us 2. 2x equals 0. So it means that x must equal 0. Clearly, x being equal to 0 does not fit inside the range of x is greater or equal to 3. So this means that solution number 3 is not possible either. So what does that mean for us? What will we write as the answer to this problem? Well, on some tests, don't be afraid to write that there is no answer to a problem. For example, in this case, there is no solution to x. This is not valid. We could write that there is no answer or that x does not have a valid solution. So this was our first approach to this problem, but we can look at this problem from another angle through the geometry angle. So first, what is the definition of an absolute value? Well, we know that the absolute value represents the distance between a certain number and 0. So technically, we're saying that two distances added together equals 2. These two distances are each x plus 5 and x minus 3. And when you add them together, you get a total of 2. So let's draw out another number line again. We have 0. And we have our two important points, key points, -5 and +3. And since x is talking about the same number, it means that there is a certain point on the number line, let's say here, where this distance to -5 and this distance to 3 is added together, when added together, equals 2. So is this possible? Well, we know that if we have 0, the shortest distance between 5 and 3 is already 8. 8 is already greater than 2. And if you try to find any other point outside of this range, for example, here, let's say, it would always be 8. It would always be 8 plus something else. So it means that the minimum requirement for this number is actually supposed to be 8, not 2. So no matter what, we can't find a point where the two distances added together equals 2. 2 is just simply too little, which means that this can also tell us that there is no answer to this problem. So there are two ways, again, to solve this second problem. One is the geometry way, and the other, of course, is the first way we used, which was to try to break this problem down into smaller steps to think about separately. So our problem is the absolute value of x and 4 plus the absolute value of x minus 1 is less or equal to 11. So what would the value of x be, or what would the range of the value of x be? Again, let's draw out a number line. As you can see, drawing a number line in these type of problems is very useful and very important. And we have to find our key points. In this case, it's -4 and +1. And again, we're splitting this number line up into 3 sections. First section, we know that x is less or equal to -4. Again, we use the same method, even though now it's an inequality, to take away the absolute value signs. Because the value we will get will be less or equal to 0, we have to reverse the symbols or the signs in the absolute values. So we get -x minus 4 minus x plus 1. As you can see, we have reversed all the signs. That is less or equal to 11. And then we calculate to get -2x minus 3 is less or equal to 11. So then -2x is less or equal to 14. So then x, remember now, since we are dividing by a negative number, we have to reverse the symbol, is greater or equal to 7. In the beginning, we already know that x is less or equal to -4. And now we come up with x is greater or equal to 7. So we have to combine these two to get x is greater or equal to -7, but it is less or equal to -4. Now what about our second solution? In the second solution, we know that x is in between -4 and -1. And as you can see, this is already a range of x, so we don't need to do any further simplifying. For the third solution, we have x is greater than 1. Since this is only 1/2 of the range, we have to try to find the other half by simplifying. In this case, we wouldn't need to switch or reverse or flip around the signs of the absolute values. We just have to take the symbols away. So we have x plus 4 plus x minus 1 is less or equal to 11. We have 2x plus 3 is less or equal to 11. Then we have 2x is less or equal to 8. So then we have x is less or equal to 4. After this, we can combine what we have to get x is somewhere between 1 and 4. Now let's try to express this on the number line. We have this first solution, which is x is between -7 and -4. Let's use a different color here, this magenta color. And then for the second solution, we have x is in between -4 or 1. So -4 and 1. And for the third solution, we have x is in between 1 and 4. As you can see, this entire shaded magenta area is the range of the value of x. And since they are all connected, we can turn this into a union of all of these ranges. So what is our furthest point? As you can see, it's -7, and the most right point is 4. So x is greater or equal to -7, but less or equal to 4, +4. So that would be our range for the value of x. That is still our first method. What would our second method be? Again, we can draw out a number line. We have 0 in the middle, and we have to draw out our key points, -4 and +1. Again, we can think about this using the basic meanings of absolute value. We know that two distances, x plus 4 and x minus 1, added together must equal a total distance of 11. And remember, x is the same point, so we have to find a point on the number line where the distance of it to -4 and the distance of it to +1 added together is less or equal to 11. So first of all, what is the distance from -4 to 1? That is 5. So this entire section could be true. After all, 5 is less than 11. But this is not the final solution yet. There is still more. X can also be on the outside of -4 and 1. So what we're trying to do is we're trying to find a point where its distance to -4 plus its distance to +1, these two distances added together will give us a number that is less or equal to 11. So in order to find what this distance could be, this distance that's repeated twice could be, we can write out an equation. 2x, x is this distance over here, and as you can see, it gets repeated 2 times. Plus 5, we already know that 5 is our number, is less or equal to 11. We can further simplify to get 6. And so x is less or equal to 3. So it means that the furthest value x could be is 3 units away from -4, which is -7. Or it could be 3 units away from 1, which is 4, +4. So this entire range from -7 to +4 is the value for x. And as you can see, we've found our answer. Again, it's the same answer. X is greater or equal to -7, but it is less or equal to 4.